There are two ways of making atomic bombs and nuclear power station. The first way is to get a big nucleus and have it split apart. Splitting apart is called fission. Just like fish and chips, spelled a little bit different. Fission. Fission is a large nucleus that we dig out of the ground. Rocks in Australia and Russia and Iran has some. The rocks contain the element, the biggest natural element in the world, the biggest one on the periodic table that's not man-made, the biggest one called uranium. Now uranium, like most elements, it's an ium. Uranium is named after Uranus. Uranus, the second or third biggest planet? Maybe third. Biggest planet in our solar system. This was the time when new elements, when they were discovered, were named after planets. Uranium after Uranus. Yes, some people say Uranus. No, Uranus. He was a god. Anyway, yes. Get a big uranium atom and it splits apart. Now they do this all the time, but what you want is all the atoms to split apart really quickly, getting all the energy. From each atom splitting apart, you get a small amount of energy, enough for like a match or a small flame. But because you've got billions and billions of uranium atoms all in one rock, billions and billions going off all at the same time, gives you boom, atomic bombs. They used one on Hiroshima and one on Nagasaki, totally destroying the cities. Let's hope nobody uses them anymore. Anyway, so what happens is the uranium nucleus, the nucleus where all the protons and neutrons are, the nucleus splits apart. So it's splitting the atoms. Now the neutrons, neutrons, and the protons, protons and nucleus in the middle. Because protons are positive, P for proton, P for positive, protons are positive, they're repelling one another, plus repels plus. And there's too many, 92 protons all in one place is too much, and bang. When it's in the rocks, you just get one going off every couple of seconds. You get a tiny little amount of heat. But if you get lots of them all going at the same time, nuclear bomb. Or, not quite so many of them going off every second, you get nuclear power stations. Be careful with those nuclear power stations. You don't want to go boom. That's why they've got boron control rods and lots of safety systems. So, a small amount of mass, just 1 gram, is used in a nuclear bomb. 1 gram turns up into an enormous amount of energy using Einstein's equation. Hold on, Mr. One Stone, Einstein, I've got him here. Mr. Einstein's equation, oh yeah. Ein means one in German, and Stein means stone. Mr. One Stone. Einstein says that E equals mc squared. E equals mc squared was his equation that he figured out just before the Second World War. And then other people went, hold on a minute, C, that's the speed of light. That's 3 with 8 zeros. 3 times 10 to the 8. That's 3 with 8 zeros squared. 3 squared is 9. 8 zeros times 8 zeros is 16 zeros. 9 with 16 zeros. 1 kilogram. Mass is always in kilograms in equations to make them work. 1 kilogram will make 9 with 16 joules of energy. 1 gram will make 9 with 13 zeros joules of energy. That's why it's a Big Bang. So, There's nuclear fission, which is pulling the nucleus apart. Nuclear fission on uranium, or if you've been doing nuclear fission for some time in your nuclear power station, one of the products of nuclear fission is plutonium, named after Pluto, because there's Pluto, there's plutonium. So some of the uranium turns into plutonium. Oh, that's Uranus. Some of the uranium turns into plutonium. You get plutonium out, and then you can use this in a fast breeder power station to make even more nuclear energy, or the plutonium can make even more dangerous nuclear bombs. Be careful out there, people. Plutonium. It's dangerous. We're looking for it all the time, just in case. Now, so that's nucleuses breaking apart. The other way to get energy is to start with small ones and put them together. Now, there are 3 types of hydrogen. There's hydrogen, there's hydrogen, deuterium, and tritium. Tritium, means it's got 3. It's got a proton and 2 neutrons. Deuterium, means it's got a proton and a neutron. These 2 can be found in ordinary water. They're 1 in a trillion, 1 in 1,000 trillion. They're quite rare, but there's enough of them around. If we can get the science of them fusing together. Now, the word fusion comes from fusing. Hold on, fusion. Fusion restaurants fuse together Eastern food and Western food. And so you get fusion restaurants. Fusion for your hair extensions, they get some hair and they fuse it to your hair. Yeah, maybe I could do with some. Fusion is like gluing 2 things together. Fusion restaurants, fusion hair, fusing things together. A fuse, an electrical fuse, melts and becomes a blob. Well, the wire melts and becomes 2 blobs. Fusion. Fusion is the neutrons and protons of deuterium and tritium, those 2 isotopes of hydrogen, 2 different types of hydrogen. They're all hydrogen because they've all got 1 proton in them. They got more neutrons, making them, well, more dangerous. The deuterium and the tritium crash together to make a fusion bomb. And because this is types of hydrogen, isotopes of hydrogen, this is called a H-bomb. Atomic bombs are uranium, fission bombs, they're atomic bombs. But a hydrogen bomb is a particular type of atomic bomb doing fusion of hydrogen isotopes. Very nasty. Good. Excellent. Fusion and fission. Fuse, fission.